So what if I told you that this scene right here that looks like taken from a Hogwarts Legacy game is actually done by using Vue components? Hola chamas y chamos, welcome back to Álvaro Dev Labs. Since we released a new version 2 weeks ago at Vue.js Live London, and also we made the library public live on the stage, the previous videos of getting started with 3D on Vue with TresJS and basic animations with the Tres render loop became obsolete. Why? Because TresJS is now based on Vue Custom Render API, meaning that it's more performant and easy to use, also way more maintainable for us. And that includes several breaking changes. So let's get started with our video today. So before we jump into actual code, let me explain you briefly the different parts that make up a 3D scene. First, we have the objects. The objects can be a sphere, it could be a plane simulator, the floor, it could be a light, it could be the 3D model of your favorite character, you name it. Then we need to be able to see it, and that's where the camera comes. The camera will create a snapshot of all these different objects, their positions, their colors, etc. And we're gonna use it to render the scene into a canvas element. All these objects and the camera is what we call a scene. And this is the one that is rendered. To be able to render this in the browser, we need an API called WebGL. So WebGL is really low level and it's quite difficult to work only with that. So that's why the ThreeJS library exists. So ThreeJS is a JavaScript library that does exactly that, make our life easier when dealing with WebGL. You can check in the webpage, they have a lot of cool demos and they have an extensive documentation and examples. But in this tutorial, we are talking about TresJS. So TresJS is just a wrapper around it that uses a custom render API from Vue to use 3GS as Vue components. So now that we covered the basic of 3D on the web, we can start using the TresJS. So if you go to the tresjs.org, you're gonna check the documentation here, and if you click in Get Started section, you're gonna be directed to this page right here, where I have an example of a basic 3D scene and some instructions on how to install it. So in my case, I'm probably gonna use pnpm, but you can use the package manager of your choice. I'm going to install it by using NI. NI is a package that allows you to use any package manager by reading the log that you have in the repository. And I'm going to install 3, then TresJS core, and hit enter. If you want to have TypeScript support, you will need to install as well the types from 3 as a developer dependency. Why is that? Because TresJS automatically inherits all the types and interface from 3JS into the Vue components. So that's the only way that you will have a complete intelligence in your IDE for using TresJS. Also, I forgot to mention that this application is just a Vite application that I created from scratch using Vue. Okay, it doesn't have anything else. And we can run it by doing nrdev. Okay, and here we're gonna see the results. So if I put something here, then we have something in the DOM. Okay, cool. Now we can start. First, we're gonna remove the code that we used to see if the application was working. Okay, and we're gonna import the TresCanvas component from the Tres core library. So we're gonna do import TresCanvas from TresJS core. And then we're gonna use it on the template. We're gonna open a new component here called TresCanvas. The TresCanvas component is the one that is going to render into a canvas element into the DOM. So how we can see that is here, we're gonna open the DevTools and we're gonna go to the div app right here. Let's click save, okay? And now inside of the div app, we're gonna see that there is a div, and inside of div, there is a canvas element. So the library is working, but the canvas, you can see that it has a height and a width of 0. That's because TresCanvas takes the width and the height of the parent container. So if this div right here, it has this size, it's gonna take that size. So if we want to use the TresCanvas correctly, we need to add some styles. So here I'm taking the HTML, the body, and the div with the ID of app, and I'm setting a height and a width of 100. If I save now and try to look back for a canvas, now we can see that the canvas is taking the full width and height of the parent. This is a common issue that beginners have when using TresJS for the first time. It's important to check the size of the canvas if you're not able to see your scene. Now that the canvas has the correct size, we can also check here in the attributes if ThreeJS was mounted correctly, which it does, because here you can see the data engine in the canvas element, and it says TresJS R152, which is the latest version, okay? And you have the data scene ID. So it is working, but why we don't see anything is completely blank. Let's try adding a color to the TresCanvas. So if we use clear color and we pass a color like this, okay, and we click save, we notice that the canvas is still blank. And that's because we haven't added a camera yet to be able to see the scene. So let's do that. Inside of the TresCanvas component, we are gonna add a Tres perspective camera. So it's important that all the elements, objects that you create, you need to create them inside of the TresCanvas, otherwise it won't work. So remember when we were talking about the elements that a 3D scene has? The first one is the camera. So if we click save and we refresh, we're gonna see that now the color is applied to the background because we actually have something that is recording the scene, which is this camera. The perspective camera is the most used one because it's similar to how the eyes work or how the cameras in cinema or in TV work. Okay, so now that we have something in the DOM element, let's add some objects. So the way to create objects is really simple. We're gonna go here and we're gonna say Tres Mesh, okay? And inside of the Tres Mesh, we're gonna pass two components as slots. We're gonna pass a Tres Box Geometry, okay? And we're gonna pass a Tres Mesh Basic Material. So let me explain you a little bit how this works. The Tres Box Geometry or any geometry is basically the structure that the object will have. It's where the pixels of the vertices are gonna be. Then the material are the visual properties of that object. It means the color, it means how reflective it is, if it has a texture, so on, okay? These two things together are a mesh, which is the same as an object, okay, in 3D. So if I click save here and I refresh, now we see a completely blank cube. Okay, that's because we haven't passed any parameters to our stuff. We're using a mesh basic material. We're gonna have another video about the different kinds of material. This is the most basic one, okay? And the same as view, you can pass properties. So in this case, we're gonna pass a color and we're gonna say color teal. Now we have a cube with a different color. What is TresJS doing right now is taking whatever you create as view components and translating it into TresJS code. If we wanted to do the same with plain TresJS, it will be something like this. We will have the scene, okay, which is gonna be like new scene with a constructor. Okay, supposedly I don't know how to write a scene, okay. This is coming from tree, okay, so it's a constructor or like a class that is inside of the tree library, okay. Then we will need to create a geometry like this and say new box geometry. Also, we need to import it from a tree. And the material will be something like this. Material equal new mesh basic material, also from TresJS. So we need to import it as well from here. And then cons box or mesh is going to be equal to a new mesh. Okay, the geometry and the material. Okay, and then we will need to add it to the scene. So it's gonna be like a scene add box. So this is the way how TresJS work. And this here is exactly the same as this, just that TresJS handles everything for you. If you have worked with TresJS before, you probably know that you can pass arguments to the geometry, for example. So that's the next topic, arguments. Let's talk about arguments. So whenever you're creating a geometry, for example, in plain TresJS, you have some parameters that you can pass to the instance, such as the width, the height, and the depth of the cube. Okay. And if I do something like this, I'm gonna create a box of width 2, height 1, and depth. So how we can do that with the view components? The way of doing it is that you are going to use the property called arguments or args. And this is accepting an array of parameters. In the same order that the ones of a TresJS work with width, height, and depth, you can add here. So the first one is going to be the width, the height, and the depth. Okay? We're going to do 2, 1, and 2. Let's click save. And then we're gonna see that the cube has a different dimension. Okay, so let's talk now about props. And we have been using props since the beginning. When we start passing a color to the mesh basic material, we were using props. So we're going to use props to modify the tres mesh, to locate it in a different place of the scene, and also modify the rotation and how big it is. To help us visualize it better, because right now we have only 2 colors into the scene, I'm actually going to change the basic material. So I'm going to remove the color here, and I'm going to use one that is called normal material. If I click save, you are going to see now it's indicating the different faces of the cube with different colors. Now, also, we are going to add something that is called TresAxis helper. So the TresAxis helper, and let me remove real quick the cube so you can see it better, is just basically 3 vectors. One that indicates the y-axis or how high you are, then the x-axis or the x-axis of the width, and the zeta axis or the depth. Okay? And this point here, when they intersect, is the center of the scene, or the coordinate 0, 0, 0. If we get our tres mesh again into the scene, we're gonna see that it's located in the center of the scene. So how do we modify the position of our tres mesh? Here we can pass a prop that is called position. And position accepts an array. This array is just basically the x value, so let's put 0, the y value, so if we want to move it up, we can move it like 2 positions, for example, and then the zeta value. If we click save, we're gonna see now that the cube has risen up. Maybe we can do like 1 and move it a little bit down. And if we want to move it horizontally, we can use the x value like this. Or if we want to move it in the zeta value, we can use this one right here. So now you can see how to move the cube in the scene. Let's put it back to, I don't know, 0.2.0. Okay, maybe 1, so it's available here. And let's change the scale. So another transform is this one. Similar to the position, you can pass an array. And you're gonna say how much you want to deform the cube in the x-axis. So in this case, we're going to maintain it into 1. In the y-axis, so let's say 2. And in the z-axis, so let's put half of it. If I click save, you are going to see now that it looks more like a rectangle because we tell it to duplicate the height, cut in half the depth of it, and maintain the x value. Also, we can rotate it. So if we add a third one, which is called rotation, rotation works in a similar way. It's getting an array, and you're going to tell in which axis you want it to rotate. So I'm going to say 0, 0, 0 and show you the different ones. If we want to rotate it in the x-axis, we're going to use math pi. Okay? So in trigonometry, pi is 3.1415 something, okay? And it represents 1 round, okay? Or 1 spin. So if I click save, you're going to see that it's exactly the same. If I say something like a quarter of that, now you're going to see that it's rotated in the x-axis, so it's rotated in this axis. Now let's say that we want to rotate it, okay? We have it like this, we want to rotate it in the y-axis. So we can do something similar here and say math pi between 2. This is half a turn, okay? And now you can see that it has moved like a door, for example, something like that. This is the way that you can transform your objects in the scene. But is only the Tres mesh capable to be edited? No, almost all the objects are able to be transformed this way. I'm going to remove the scale and the rotation here, okay? And I'm gonna show you how you can do the same with the camera. So you can pass to the camera a position. And this position, in the same way, is going to be an array. So in this case, let's maintain the x-axis. I want to get further, so I'm going to have 4 and 4. But if we refresh, we're going to see that now we don't see the cube anymore. Maybe if we could put something a little bit smaller. Now we can see that actually we're inside of the cube, right? So something is not working right. If we put 4 here, for example, we now see it, but we only see one face of the cube. So we are moving the camera. Let's put 4 and 4 again, okay? We are moving the camera, but we are not moving where it's looking at. We are moving the camera, and of course, the objects that were in the first room are no longer there. So what we need is to say to the perspective camera, hey, look at the center of the scene. So we can say 0, 0, 0. And now the camera, even if it's moved in the y-axis and in the z-axis, is gonna look at the cube. Or, well, in this case, it's looking at the 0, 0, 0, but we could even pass the position of the cube. Let's try that. And now you can see that it's centered on the cube. And with our cube right here, congratulations, you managed to render your first scene using TresJS on Vue. If you want to learn more how to use TresJS to add 3D to your Vue applications, make sure you subscribe to the channel and get more videos like this one. We will continue this series on a playlist of how to use TresJS the basics. Also, you will find all the resources that you need on the description below. Drop a like here if you find this video useful. All your questions, you can ask them in the comment section below. Make sure you have fun and see you in the next video. Ciao, ciao.